This is numbers 25 through 29 on the Unit 1 study guide. So number 25, it says we're supposed to simplify, and I notice right away that I have a 3 outside here, which means we're looking for sets of 3. So the first thing we want to do is we want to actually do the prime factorization of 125, because we're going to need to know that. So that would be 25 times 5 here, and then 25 would break up to 5 and 5. It's actually a perfect cube. And then we've got x cubed at the top. And then if you want to look at the 8, because that's in the denominator, and we're actually going to have to take the cube root of 8 as well. 8 would be 2 times 4, and 4 breaks into 2 and 2. So again, that's a perfect cube. So what we've got here is if we split this off, so we're going to find the cube root of 125x to the third power over the cube root of 8. What we've got is the cube root of 125 is 5, because there's 3 of them. And then the cube root of x cubed, think about that, that's 3 x's, which makes a pair of 3, which is what we need, so we pull it out. All of that over the cube root of 8, 3 sets of 2's would make it 2, so this would be our final answer. On this one here, number 26, has got a little bit more work involved because we need to simplify both pieces before we can actually subtract them. So I'm going to start up here so that you can see how we're doing this. And so the first thing I'm going to do is I'm going to start with 54 and break it off. So I've got 9 times 6 would be 54. 9 breaks into 3 and 3. 6 breaks into 3 and 2. So if I were to simplify 4 times the cube root of this 54, which is 2 times 3 times 3 times 3, and then I've got 4 x's, so 1, 2, 3, and 4. I'm looking for sets of 3. So I found a set of 3 here with the 3's, and I found a set of 3 here with the x's. You pull out one of each and multiply to the outside, so 4 times one of these 3's would be 12. So we have 12. And then we pull out an x here, and then we still have left the cube root of what's left inside, a 2 and an x. So that's the first piece, and we'll have minus. Now the second piece that we need to do here is this x cube root of 16x. So for that, I'm running a little out of space here. I'm going to go ahead and move that here to the bottom, and we'll come back up. But that would be x cube root of 16x. So we want to break up this 16, which would be 4 times 4, and then 4 can be broken into 2 and 2 and 2 and 2. So this means x cube root of, let's look at what we got. We've got 1, 2, 3, 4, and then an x on the inside. Here's our triple. You get to pull it out and multiply it with the thing on the outside. So that's 2x. That takes care of that. And then still inside this cube root is a 2x. So that's what I'm going to replace with this x times cube root of 16x right up here. So I have minus 2x cube root of 2x. So now let's go back to this problem up here, because we've now simplified both of these. For them to be like terms, behind the coefficient, behind the number, should be an exact match. So let's look. The coefficient is 12 and negative 2. Let's see what's behind them. They both have an x, they both got a cube root, and they both have a 2x. They are a perfect match, which means these are like terms. So we combine them. So 12 minus 2 gives me 10. And remember, when you add or subtract like terms, all you add or subtract are the coefficients. What comes behind them stays exactly the same. So this would be your answer for this problem. On number 27, it says that we're supposed to circle all of the irrational numbers. Remember, there are 3 types of irrational numbers. Pi in any form. When you see a dot, 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 like 3.21 dot, 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 because that means that this is a non-terminating, non-repeating decimal. And lastly, the square roots or those cube roots of non-perfect numbers, like the square root of 50. It does not turn out to be very pretty. Or how about even the cube root of 50? So with that, if it's one of these types, then it's irrational. If it's not, it's rational. So I see a pi in this first answer. That has to be irrational. Then I see a fraction. Is that pi? No. Does it have that dot, dot, dot? No. Is it a square root or cube root of a non-perfect number? No. So that one's rational. Here we come to this one. Is that pi? No. Does it have a dot, dot, dot to show it's a non-terminating, non-repeating decimal? No. Is it a square root of a non-perfect number? No. So that one's rational. If you look at this, square root of 81 is 9. So is that pi? No. Is it a dot, dot, dot? No. Is it a square root of a non-perfect square? The answer is no, because the square root of 81 is 9. So that one's rational. You come to this one. Is this pi? No. Is it a dot, dot, dot? Well, you have to be careful because this is a repeating decimal, but the definition is a non-terminating, so that's what this is, but it also has to be non-repeating. This repeats. This is actually rational. And then the square root of a perfect square, perfect cube, is it one of those that are non-perfect? The answer is no. This one, is it pi? No. Is it a dot, dot, dot? Yes. If you see this dot, dot, dot here, it means that this is a non-terminating, non-repeating decimal. And finally, our cube root here of 125, which happens to be 5, which again does not fall into any of these categories. So these are the only two irrational numbers in this set. On number 28, it says, which of the following correctly describes the product of a rational and an irrational number? Well, let's look. Let's take a rational number 5 times an irrational number like the square root of 2. If we multiply them together, that's going to give me 5 square root of 2, which this is a square root of a non-perfect number, so this is irrational. So the rational times the irrational gave me an irrational. Well, what if I did 0 as my rational? 0 is a rational number times the square root of 2. What's that give me? That gives me 0. So now I have a rational times an irrational equals a rational. So which of the following correctly describes that product? Both rational and irrational. Well, it can't be both at the same time. Always irrational. That's not true because I just proved it could be rational. Either rational or irrational depending on the rationals used. That is true because it depends on which number I pick for an for a rational number. So it's got to be C. All right, number 29 says, which of the following correctly identifies the solution to this? I have 3/5 minus the square root of 7. Those are not like terms, which means that is also the answer. And it has a radical of a non-perfect number, so I can't take the square root of 7. It's an ugly looking number. So that means that this has to be irrational, which makes it answer choice B.